Look up at the night sky. On a clear night far from city lights, a faint band of light stretches across the heavens. This is the Milky Way, our galactic home, a vast city of stars, gas, dust, and mysteries yet to be unraveled. This is where our story, and the story of billions of stars, unfolds. We live on a small, rocky planet called Earth, orbiting a rather ordinary star we call the Sun. Our Sun is just one of hundreds of billions of stars in the Milky Way. Each star is a sun in its own right, many with their own families of planets. The Milky Way is a barred spiral galaxy, a majestic cosmic pinwheel. It spans over 100,000 light-years in diameter. One light-year is about 6 trillion miles. Imagine the vastness. Our place is about 2/3 of the way out from the center in one of the spiral arms. The Milky Way is full of activity, with stars being born, living, and dying.
For millennia, humans have gazed up at the Milky Way, weaving stories and myths around its ethereal glow. Ancient civilizations saw it as a river of milk, a celestial pathway, or a backbone in the sky. But it wasn't until the dawn of modern astronomy that we began to unravel the true nature of our galaxy.
Early astronomers, armed with telescopes, started to resolve the Milky Way's faint band into individual stars. Galileo Galilei, in the 17th century, was among the first to do so, his observations challenging the long-held belief in an Earth-centered universe.
In the 20th century, Edwin Hubble made a groundbreaking discovery. By observing Cepheid variable stars, he proved that the Andromeda Nebula was not a cloud of gas within our galaxy, but another galaxy altogether. This discovery revolutionized our understanding of the cosmos, revealing a universe teeming with galaxies.
Imagine a cosmic pinwheel, its arms swirling gracefully through space. That's our Milky Way, a barred spiral galaxy with a central bar-shaped structure. At its heart lies a supermassive black hole, millions of times the mass of our Sun. Surrounding it is the bulge, a densely packed region of stars. Extending outward are the spiral arms, long curved lanes of gas, dust, and stars. Our Sun resides in one of these arms, the Orion arm. Finally, there's the halo, a vast spherical region that envelops the entire galaxy.
The Milky Way, like everything else in the universe, has a story to tell. A story about its birth, its evolution, and its interactions with its cosmic neighbors. The Milky Way formed over 13 billion years ago, not long after the Big Bang. Gravity drew together vast clouds of hydrogen and helium gas, causing them to collapse and coalesce. As the gas clouds contracted, they began to rotate, eventually flattening into a disk. Within this swirling disk, stars began to ignite, forming the first populations of stars in the Milky Way. Over billions of years, the galaxy grew through the accretion of smaller dwarf galaxies and the ongoing process of star formation. The Milky Way is not a static island in space. It's constantly interacting with its surroundings, particularly its neighboring galaxies in the local group. These interactions, often in the form of gravitational tugs and pulls, shape the Milky Way's structure and influence its evolution.
Section 5, the Milky Way's cosmic address. To truly grasp the Milky Way's place in the grand scheme of things, we need to zoom out, way out. The Milky Way is just one galaxy among trillions in the observable universe. Our galaxy belongs to a small group of galaxies called the local group. This cosmic neighborhood, spanning about 10 million light-years, includes about 50 galaxies, dominated by two spiral giants, the Milky Way and Andromeda. The local group itself is part of an even larger structure called the Virgo supercluster. Superclusters are vast collections of galaxy groups and clusters stretching for hundreds of millions of light-years. The Virgo supercluster contains over 100 galaxy groups and clusters, including our local group. And the cosmic hierarchy doesn't end there. Superclusters are thought to be connected by filaments of galaxies, forming a vast cosmic web that spans the observable universe.
Section 6, Dark Matter, the Invisible Hand. The Milky Way, for all its brilliance and grandeur, harbors a profound mystery. Dark matter, this invisible substance which doesn't interact with light, makes up the vast majority of the galaxy's mass. Astronomers first inferred the existence of dark matter by studying the rotation of galaxies. Stars in the outer regions of spiral galaxies, like our own, orbit much faster than they should based on the visible matter alone. This discrepancy led astronomers to conclude that there must be an invisible form of matter, providing the extra gravity to hold these fast-moving stars in their orbits. Dark matter doesn't emit, absorb, or reflect light, making it incredibly difficult to detect directly. However, its gravitational effects are undeniable, shaping the structure and evolution of galaxies, including our Milky Way. While we can't see dark matter, its presence is essential for the Milky Way's existence. It's the invisible scaffolding that holds the galaxy together, allowing stars to form and galaxies to evolve.
A star's life. The Milky Way is a cosmic cradle where stars are born, live, and die. Stars form in giant molecular clouds, regions of gas and dust. Gravity pulls clumps of gas and dust together, causing them to collapse and heat up. When the core reaches critical temperature, nuclear fusion ignites, birthing a star. Stars fuse hydrogen into helium, releasing energy that makes them shine. A star's lifespan depends on its mass. Massive stars burn brightly but live short lives. Low-mass stars, like our Sun, shine steadily for billions of years. When a star exhausts its fuel, it can no longer support itself against gravity. Massive stars end in supernovae, leaving behind neutron stars or black holes.
Section 8. Eyes on the Cosmos. Unlocking the Milky Way's secrets. Unlocking the Milky Way's secrets requires peering through the vast distances of space. Fortunately, astronomers have developed an array of powerful tools to study our galaxy, from ground-based telescopes to space-based observatories. Ground-based telescopes, like the Keck Observatory in Hawaii and the Very Large Telescope in Chile, use massive mirrors to collect light from distant objects. These telescopes have been instrumental in studying the Milky Way's structure, mapping its spiral arms, and observing the motions of its stars. Space-based telescopes, like the Hubble Space Telescope and the James Webb Space Telescope, have the advantage of observing the universe from above Earth's atmosphere, which can distort and absorb light. Hubble has provided stunning images of the Milky Way, revealing details about star formation, the galactic center, and the distribution of dark matter. In addition to telescopes, astronomers use other techniques to study the Milky Way, such as radio astronomy, which detects radio waves emitted by objects in space, and infrared astronomy, which can peer through interstellar dust clouds that obscure visible light.
Section 9. Exoplanets searching for life beyond Earth. The Milky Way is home to billions of stars, and recent discoveries have shown that planets are incredibly common around other stars. These planets orbiting other stars are called exoplanets. Astronomers have discovered thousands of exoplanets, ranging in size from small rocky worlds to gas giants larger than Jupiter. These discoveries have revolutionized our understanding of planetary systems and raised the tantalizing possibility that we may not be alone in the Milky Way. The search for life beyond Earth is one of the most profound quests in science. While we have yet to find definitive evidence of extraterrestrial life, the discovery of so many exoplanets, some of which may be located in their star's habitable zone, gives us hope that we may one day find signs of life on other worlds within our galaxy.
Section 10. A glimpse into the future, the Milky Way's destiny. The Milky Way, like all galaxies, is not static. It is constantly evolving, and its future holds both beauty and destruction. One of the most dramatic events in the Milky Way's future is its collision with the Andromeda galaxy. Andromeda, our nearest large galactic neighbor, is currently on a collision course with the Milky Way. Don't worry though, this cosmic clash won't happen for another 4 billion years or so. When it does, it will be a slow and drawn-out affair lasting for millions of years. The two galaxies will pass through each other multiple times, their gravitational forces distorting their shapes and triggering intense bursts of star formation. Eventually, the Milky Way and Andromeda will merge into a single giant elliptical galaxy. This new galaxy, sometimes nicknamed Milkomeda, will be a very different place from the Milky Way we know today. Section 11. Our place in the cosmos. The Milky Way, our galactic home, is a vast and awe-inspiring place. It's a cosmic city teeming with stars, gas, dust, and perhaps even life beyond Earth. As we continue to explore the Milky Way, we gain a deeper appreciation for our place in the cosmos. We are children of the Milky Way, our very existence tied to the intricate processes that unfold within this grand spiral galaxy. The atoms in our bodies were forged in the hearts of stars that lived and died long ago, their remnants scattered across the galaxy, eventually becoming part of us. The Milky Way serves as a constant reminder of the vastness and wonder of the universe we inhabit. It's a source of inspiration, sparking our curiosity and driving us to explore the cosmos, seeking answers to some of the most fundamental questions about our place in the universe. As we continue to unravel the Milky Way's secrets, we gain a deeper understanding not only of the galaxy itself, but also of our own origins and our place in the grand tapestry of the cosmos.